This is January 06 question 4. State a quantity which is the same unit as momentum. Now at AS now you don't do momentum anymore, but I'll just put it in here anyway. Momentum is mass by velocity, and that's equal to F times T, which is impulse. So the answer is impulse. This would be relevant to year 14, so you're repeating AS1, but not really relevant to AS1 year 13s. The next part is obviously relevant though. A car of mass 1150 kilograms is travelling at 20 metres per second. The brakes are applied for 4 seconds and the car slows down to 15. Calculate the average force applied by the brakes. The first thing you have to do is calculate acceleration. And A is equal to V minus U over T. So if we just write down what we've got there, you know, initial velocity is 20, final velocity is 15, and the time applied is 4 seconds, the brakes are applied for. So A is equal to 15 minus 20 divided by 4, so it's minus 1.25. And so minus force because or minus acceleration because it is decelerating. The next part of the question, F equals ma. M is 1150 kilograms, A is minus 1.25. And therefore that gives you an answer of 1437.5 newtons, or to four significant figures 1438 newtons. The car in B is now brought to rest on a road which is inclined at a constant angle to the horizontal. The engine is switched off and the handbrake is applied, but unfortunately it does not prevent the car from moving. After a short interval, the car moves slowly with constant velocity down the slope. Explain how it is possible for the car to move with constant velocity down the slope. So if we just draw that out over here maybe, there's the slope and there's the car. We'll just draw it as a wee box. There's a weight component acting down towards the bottom of the page, or it's perpendicular to the bottom of the slope, and then you have got two components. I think I said a weight component there. It's just the weight itself. These are the two components here, and it's this one here we're interested in. It's usually this one we're interested in, and this is the one with the sign of the angle in it. So there's the angle, and there's the angle again. So this is W, the sine of theta, and that's going to be equal to the frictional force which acts up the slope, which tries to prevent it from moving. So W sine theta is equal to F. So that's the weight component. And that's the weight component which is parallel to the slope. Now, if it's moving at a constant velocity, then weight component is equal to the frictional force. And that's how it can move at a constant velocity, i.e. there's no resultant force, and therefore no acceleration. So there's a mark there, and then there would be a mark there about talking about the weight component. Last part of the question over the page. Explain how the principle of conservation of energy applies to the car as it moves down the slope with constant velocity. So as the car moves, first of all, initially, the car has gravitational potential energy. And as it moves down the slope, this is converted to kinetic energy. But if it's going to, what should happen is that all the GPE should be converted to all the kinetic energy. But what is actually happening is that the GPE, because this is moving at a constant speed and it's not speeding up, then kinetic energy isn't getting any bigger, and therefore there must also be heat lost, and that's due to work done to try to overcome friction. So kinetic energy is constant, therefore some of the GPE is converted to heat. And that's due to work done to overcome friction. And so there's 3 marks for that. Again, you would have to write that in continuous prose. But they'll give you a mark for GPE being converted to kinetic energy. And then the last mark, due to some of it being dissipated as heat, and because you're doing work, or there's work done to overcome frictional forces.